Once upon a time, there was a little community connected to a secondary substation. As the day starts, the residents of the town wake up slowly. They are getting ready to face their long day. They use household appliances. Some will take a shower, others will prepare breakfast using the microwave and the coffee machine. Meanwhile, when the sun rises, the photovoltaic system installed in some households start to generate energy. As time passes, people start to leave home to go to work, attend school or fulfill other duties. Today is going to be a sunny day and therefore lots of renewable energy will be generated. The households will not use the self-generated electricity because they are empty during noon. Then the not consumed generated electricity is sent to other neighborhoods through the distribution system. This situation causes the distribution grid to stress, and in near future it could become more and more frequent. This is because the distribution grid was initially designed to feed customers and not to collect their generation outputs. During the noon, when the panels are simultaneously at their peak, the transformer of the low voltage grid can reach its limits and saturate. In this scenario, the voltage rise can even lead to overvoltage that might damage some electrical appliances. Now the sun is setting, but during the day a lot of electricity has been sent to the distribution grid. For some days the DSO has been thinking about how to solve the situation. Should the DSO upgrade the transformer, or maybe it would be better to create a new secondary substation? Perhaps there is another way to face these situations, some ways to involve prosumers and create a local energy community. Meanwhile, the residents are coming home and electricity demand rises again. But something is not going as expected. In households, electrical appliances do not function correctly. Washing machine vibrate, TV flicker. This seems to be due to power quality issues from the supply grid. Once the sun has set, household consumption increases even more. The DSO is worried. The transformer is again struggling to handle such high consumption. Once again, the transformer is overloaded, now due to the consumption of the households. Suddenly, when the demand is at its peak, a fault happens and interrupts the power supply, leaving all households in the dark. Time passes until the DSO emergency brigade shows up to repair the fault. This is inconvenient for the residents who have to stop their activities and go to sleep in the dark. Later, the fault is repaired and the grid can be finally restored. The DSO might have found a way to manage these situations correctly. A new and innovative asset is connected to the secondary substation at the low voltage grid. It is called the power electronic device PED. PED contains power electronics, lead-acid battery, and lithium battery. A new day starts with the PED already operating. Slowly the residents wake up. They get ready to face a long day of work again, using household appliances, some taking a shower, others preparing breakfast. When the sun rises, the photovoltaic panels installed in some households start to produce energy. As time passes, people start to leave home to go to work, attend school or to fulfill other duties. Today is going to be a sunny day and therefore lots of renewable energy will be generated. However, instead of feeding to the grid, the energy is stored in the batteries of the PED. In this sense, the PED avoids the grid stress. Also, It is avoiding possible overvoltages and transformer saturation. Today, the battery will be fully charged at 100%. Now, it is needed to upgrade neither the transformer nor the low voltage grid. The residents are coming home again and the electricity demand rises again. They are using the energy generated by their solar panels stored in the batteries of the PED. Moreover, the PED has more capabilities. Acting as an active filter, the PED improves the power quality of the grid, avoiding power quality issues due to harmonics, imbalances or reactive power. Once the sun has set, household consumption increases again. In high consumption situations, PED supports the grid sharing the load. Unloading over voltages of the transformer. Suddenly, a fault interrupts the power supply. However, PED keeps energized the low voltage grid while the fault is waiting to be restored. Powertronic device, a hybrid storage solution for decarbonization of energy grids.